Alright, takamirira vamwe Leo.
Yeah, you see.
¿Cómo está?
Muri sei
Maziva
sei.
nemaprotocols.
Yeah, amaprotocols takamboma bata bata.
Yeah, izvezvi makufanira kudhipisa manje. Makufanira kudhipisa
Yeah, yeah.
kuziva protocol in and out. Because understanding a protocol
Yeah,
in and out is a very good foundation yekuziva networking. Since I'm recording, let me just go
yeah,
to ndipedzise zvese, then we can send to others usati wapinda and all. Right. So
yeah,
pangatave ndatotaura nyaya, I think that I've bundled up quite a number of things. Nyaya dze-encapsulation, de-encapsulation ipapo. Right. Encapsulation kana tiri kubva to the application up to the physical. Particle encapsulation. Maheaders nematrailers ari kuedwa. How does it happen? Kunoko, kune data kunoko. Ndo image yako yauri kusenda. Paunenge uchidzika, starting with, let's start with the transport. Start with the transport layer. Panoiswa header retransport, header retransport, header retrailer yetransport. Then data rako iri rinenge rapakati like this. Ndo encapsulation basically. Then parinodzika richipinda munetwork, this whole thing ichi chadata. Then poiswa rimwe header. Header remulayer 3. Parinodzika chese icho chadata. Poiswa header remulayer 2. That is what encapsulation is. And what is the information in my header and my trailer? The information in my header and my trailer, for now, at this layer 4, understand, let's say, ndopa nema source port, my ports, my source ports and my destination ports, layer 4. Layer 3, ndomo nema source nema destination maka IP address. Layer 2, ndomo nema source nema destination MAC address. Now kana takuenda de-encapsulation, tasvika kuphysical takudzokera uku. Maheader aya akubviswa. Paunobvisa maheader, madevices paanobvisa maheader, layer 2 switch ndo rinotanga kubvisa maheader. Parinobvisa rotarisa the MAC address. Is the MAC address destination for a device riri munetwork yangu randinoziva, or destinated to me as a device? If yes, then ndo parinoremovha rokwidza kumusoro kuti rinotariswa palayer 3. Rikatariswa palayer 3, layer 3 rotarisa IP address. Is this destined for this network? Yes, rokwira kumusoro, robviswa futi. Masource nemadestination ports, destination port nderangu here? Ehe, nderangu. Zvinoti message ndeyangu yokwira, yoitwa yopinda mupresentation, yoitwa decompression, de-encryption, yokwira. Then we can finally see our message. Basically, that's the easiest way to understand how my protocols interact. This is basic. Now, with more studying, muchifamba one this background, you can go understand and send a message what is happening. Now include kuti my protocols rakati role yarino play ndeipi panapa. And understanding yako yema protocols will improve from there. Let's try to finish. My standard organizations. Who akataura kuti tofanira kutaura chirungu kuti tinzwanane. Let's say tikutaura English, tikutaura Ndebele, mumwe akutaura Shona, but we find a compromise kuti let's speak English kuti tinzwanane. Who said we should do that? In humans communication, is probably the British. Nelanguage yavo vakataura kuti kana musiri kuziva, we have a universal language. That is a standard. My British in networking, my organizations are up, if I can put it that way. They are organizations which are responsible for setting the rules for network communication. Right? My standards are, we have example, ISOC. I'm familiar with ISOC. Promotes open development and evolution of the internet. I'm familiar with not these ones, IETF internet standards. Let me look at these ones. I'm familiar with IEEE. I'm sure as my engineers, you're all familiar with IEEE. My standards edu atinoshandisa anobva pana IEEE. For example, I know of 802.15. I'm sure this is our Bluetooth. IEEE 802.15. I'm familiar with 802.11 Wi-Fi. 802.11. A couple of IEEE standards. I'm familiar with these ones. So IEEE, those are the organizations which came up with those standards. And make sure everyone, every vendor, they adhere to those standards. Why? Tinema standards. I think the reason is here, they interoperability, competition, innovation. They encourage that, my standards. Without my standards, without my organizations making sure that every vendor adheres to those standards, we'll probably have a case kuti munane kambudzi Nokia cannot call munane iPhone latest. But because we use the same standards, munane kambudzi nemunane iPhone, my way, battery rangu gone. Munane kambudzi nemunane iPhone, they all use the same standards. Saka kana wachishandisa ma same standards, it means chero ndikafonera munhu ane iPhone anodaira. Just a minute. Right. So it's because of those standards, the interoperability. Dai Android some iPhone communicate without my standards. That's why we have my standards basically. Right? Standard organizations are vendor neutral, non-profit organizations established to promote concepts of open standards. I think I've touched on my standards. I'm familiar with IEEE. What else? I'm also familiar with ITU. But you need to study and see what my organizations SI and energy. Just highlighting organizations I interact with. I interact with IEEE. I know of that one. I know of ITU. These standards, for example, ITU. Minister Weldwe ICT was in Dubai, I think, past month. They decide with the, for example, my frequencies are shandiswa over the radio. Telecommunication basically, my frequencies are shandiswa the app and I know shandiswa. My frequencies SAS angoshandiswa ukashandisa frequency siriyo unogona kusungwa. Kana izvo zvinhu zvokaita radio yako zvinogona kusungisa because kushandisa mafrequency aunenge usina kunzi ushandise. We have my frequencies are licensed, etc., etc. And who is responsible for knowing that my frequencies are licensed, they are unlicensed? It's ITU, for example. So we have my organizations which make sure my standards, they are being followed. Right, reference models. Up and depends on Apple Darab. OSI model TCP IP. What is the similarities? What is the differences? You need to be able to identify what the three layers are. The Kamabata needs Eco OSI and about one layer of TCP application. Transport remains the same. Network running around the internet. Two and Kamabata needs network access. My protocols in each of the layers, they remain the same, they operate the same. Just two different models of Shandish. Right? This one is more theoretical. This one, OSI, is more theoretical. This one is application oriented. You can actually apply it and see it background practical. Right? Benefits of using layered models. I've discussed the benefits already. Interoperability. If you want to see the benefits of my layered models, one, interoperability. Kana tese tichifollowa the same model. it means tinokwanisa kuva innovative, kugadzira zvinhu zvakanaka, kugadzira maiphone anodhura, but tinokwanisa kucommunicata anyway. We can be innovative. Why tiri kuva innovative is because we are using the same model. We want to beat vamwe vanhu vari kushandisa kambudzi or vari kushandisa Android. So those are the benefits dzekushandisa ma-layered models. Since tese tiri kushandisa one model, inini I'm going to be more innovative so that ndikwanise kusela device rangu. Mamwe ari more technical, kana takupinda panyaya dzetroubleshooting, ma-layered models, they help us in troubleshooting. How? Troubleshooting yako, you can start troubleshooting at the lowest layer, which is the physical. Wotarisa kuti paphysical, what is happening? I know kuti ndokwanisa kutarisa kuti makebho angu hapana yakadambuka here, makebho akakonectwa zvakanaka pamaports here, ma-physical devices angu aisari kufunctiona here, ari on here. I'm troubleshooting at the physical. Ndopinda padata link, ndoona kuti ma-MAC addresses angu ese ari proper here. Ndopinda pa-layer number 3, network, ndoona kuti ma-IP addresses angu ari correctly configured here. Troubleshooting, network iri down, ndotsvaga kuti network yakadhakwa papi. So with my layered models, it makes it easy because ndofamba layer by layer ndichitarisa kuti chii chiri kuitika muneo, zvese zviri right here. Zvikurati kana physical layer riri kufunctiona, problem iri probably palayer 2. Layer 2 kana riri kufunctiona, problem iri palayer 3, up until ndasvika kulayer 7. It helps us with that. Right? Here I've already dealt with this part. You need to know that each layer rinoitei straight from the head. Application layer responsible for chi up until to the physical layer. Very small phrases. Dzaunofanira kubata dzinokudza kuti each layer rinoita nezvechi. TCP IP, same thing. Comparison, packet tracer, data encapsulation. Data encapsulation, we've talked about this. Putting my headers, never trailers per message. Segmentation is breaking down a message, reducing its size. Why? It increases the speed, it increases efficiency. Large amounts of data can be sent over the network without tying up a communications link. So we can send large amounts of data since we are going to segment that large amount of data into smaller sizes. That's segmentation for you. Segmenting a message, sequencing. After you've segmented, you need to sequence it, to number it, so that by the receiving end, you can rearrange the message with a proper message again. Protocol data units, very important. Patinator encapsulation here, a process where protocols add their information to the data. Encapsulation, right? Patinator encapsulation here, you need to be able to recognize my PDUs. Kuti kana ndichibva ku-application presentation ne-session layer, PDU rangu rinenge richinzi data. Information yandiri kusenda inenge ichinzi data. Ndikadzika, ndikaita encapsulation pa layer 4 pa transport, information iyo yakunzi segment. Ndikaita another encapsulation ndichidzika pa layer 3 rakunzi packet. Pa layer 2 rakunzi frame. Patinosvika ku-physical layer anenge akunzi ma-bits. Do anonzi ma-protocol data units iwayo. So you need to be able to identify and recognize these PDUs. So that kumberi uko, ndichangotanga kutaura kuti frame, I'm sending a frame, ndichaona kuti frame rangu richafamba sei, ndichadii. Iwewe automatically unotofanira kutoziva kuti kana ndikutaura nezveframe ndiri mulayer 2. Kana ndichitaura nezvepacket, ndiri kutaura neinformation ndiri mulayer 3. Kana ndichitaura nezvedata, taku-application layer. Kana ndichitaura nezvemabits, zvinoti I'm talking about the physical layer. Automatically, you should be able to recognize my PDUs. Encapsulation example. Right. This is an example of encapsulation. Right. We have data ready now. Do information at true sender. Pa layer 4, do add the information. Ye TCP. Now you can see with the PD ready on segment. But now, Pandora sender IP information protocol information yelayer 3 IP addressing rakunzi packet, pandinosendera layer 2 rakunzi frame. So encapsulation basically pandaedera information iyi panapa ndamu layer number 4, that is encapsulation. Then pandinopinda mune rimwe layer ndowedzera rimwe for information encapsulation. Pandinopinda pane rimwe layer ndowedzera imwe information encapsulation. Pandinozosvika kuphysical layer chinenge chiri kusenzwa chinenge chakaita something like this. Ichi ndo mabhitsi edu zvanenge akaita, anenge ane information yeethernet, MAC address, IP address, masource ports, destination ports, then ine information. Patinoita de-encapsulation kungovhura ndobvisa this ndotarisa muethernet ndotarisa maMAC address kuti akaita sei, ndobva ndakwidza de-encapsulation ndobvisa ichi ndovhura ndobva ndatarisa maIP address, ndovhura ichi ndotarisa sequencing yangu, maport numbers angu, then ndosvika painformation yangu, then I can view information yangu ndiri kuapplication layer. That is basically what is happening. De-encapsulation dealt with that already. Data access, right? Both data link and network layer use addressing to deliver data from source to destination, right? Data access is basically talking about my addresses A to A layer 2 ne layer 3. How do I know to send information kunani? I know by the addresses. Two types of addresses that now my addresses a layer 2 ne layer 3. The difference between those addresses, let me use devices on the same network. Let me use that to let me use this diagram here to explain the difference between my layer 3 and my layer 2 addresses. My layer 3 addresses, they are used most importantly to a remote communication. If I'm communicating with a remote network, now as we go, no kuti ndikaisa router pana network ish, network ish, this network, two my networks are remote, network 1 remote 2 are remote. Muno kana mune device irimo muno ichida kucommunicate device iri kuno tinoti communicate ne remote network. Device iri muno communicate device iri muno, that is a local network. Two different things, right? So two my devices are muno communicate. I don't want to communicate using MAC only. It's okay. MAC addresses, layer 2 addresses, it's okay. But can now communicate these two devices? MAC address only doesn't work. You need an IP address to communication it. How does that work? Let me see if I can find a diagram proper to explain that. How does that work? Same IP network. Devices on a remote. All right, let me use this diagram. Devices on a remote network. Right. So what happens when PC1 tries to communicate with WebSafe? Right. Let's start with if PC1 wants to communicate with this. Let's say this is a safe. Right. PC1 is communicating with something local. Router rangu iro. This is a network. ELAN-ish. Router interface rangu, it leads me to only one network. For now, let's say it leads me to only one network. Later on, we'll see that there can be many networks. But for now, every router interface, it leads to a different network. So, panamba isa router pandakadai so, e network guy, e network guy, e network guy. Right? Right. So, panapa, zvese zviri is safe PCE, they're in the same network. By default, kuti vari kushandisa interface one router iyi. Zvavari in the same network. Kana ndiri send information from PC1 to server, I can use my MAC addresses only. I can use my MAC addresses only. So, if I say MAC address yepa server pangu panapa is B, etc., like A, rapa. Zvira kuti frame rangu pandinorisenda. Just a minute. Same IP network. Right, let me use this one. Ritoripo kudhara. right? PC ish this, they're in the same network. Frame rangu pandinosenda, you see kuti the destination is CCC, which is here. The source is AAA, which is there. Frame rangu, that's the information irimo, right? Even packet rangu, information iri packet mangu is the address iri apa ne address iri apa ishi. Okay, my battery is low. Hakuna magetsi. PC yangu yakuita mafanisi. Pa packet rangu, information iripo ndeishi. Source 1110, destination 9. It's very easy kana tiri musame network. So kana tiri musame network, MAC address iri very easy to identify, IP address iri very easy to identify, is the same. Kana tiri pa different network, if I go back a little bit, ndati MAC address inoshandiswa pa local network. Zvinoti I can use AAA in a CCC to send my message very easy. Not considering with IP, I gotta say, I can do that. But in the kind of a remote network, watch the difference. In the kind of a remote network, now I'm sending information from PC1 to this web server. Web server is on a remote network because it's not on the same network the PC. Watch what happens kuma MAC addresses edu. MAC address ichashandiswa panapo pa frame ready. Tine source, which is the source here. Pa destination, hatina MAC address here panapo. When we are doing per same IP network, you can see that the source is the source. The destination is the destination. But kana tapa remote network, MAC address haibudi network. The destination iripapa is the MAC address of the router interface pachabuda ne frame ready. So that explains when I understand what MAC address haibudi network. So the destination inoiswa pa frame ready is the MAC address of the router interface. Then kana yasvika pa router panapa, ndo richaziva kuti ichafambisa sei, younza panapa, younza panapa. Kana rasvika panapa, although process yeARP isina kubvunzwa, isina kutaurwa nezvayo in this case at this level, ndo painotangira panapa. Tasvika panapa hatisi kuziva kuti MAC address iyi chii. ARP ndo painoita take over yobvunza kuti ndine IP address yakati, what is the MAC address? But the key thing to take here is the difference between MAC addressing pama local networks ne MAC addressing pama remote networks. Pama local networks, destination MAC is the destination kuri kuenda frame rako chaiko pama local. Pama remote, destination MAC is the MAC address of the router. Kana ndiri kuita remote is the MAC address of the router interface pari kubuda ne frame ready. Kuma IP addresses though, kuma IP addresses kana tiri pa local, destination IP is the IP address ye server, source IP is the IP yepanapa. Pama remote networks has changed. Destination IP is the IP address yepanapa, source is the address yepanapa. We can see from network iri panapa, destination yedu iri apa, yakafanana ne iri apa, source yakafanana ne iri apa. So IP, whether remote, whether local, the destination and the source has changed. But for MAC address, kana iri remote, the destination changes. Inotora the default gateway. I hope this is well understood. So the key is two, the difference between MAC address ne IP address, and why tine two types of addressing, MAC ne IP. Why not just use IP to regular shansa MAC? The reason why we don't only use IP, they could at times IP no change. So if you look at IP address iri paserver panapa, okay, yeserver really it can be static. Let's say IP yepa PC. Iwewe ukasvika pawifi, IP address yako unopiwa IP address neprotocol rinonzi DHCP. DHCP rinokuassign IP address. Rokupa IP address yako, let's say 192.168.10.10. Wapiwa IP address. Wasvika pawifi. Inini kana ndichikusendera information ndichishandisa this IP address, ndogona kuhwina for some time. Wandiudza kuti IP address yangu ndei yandapiwa neDHCP. Ndogona kuhwina for some time ndichikusendera information using that. I'm not using the MAC address. But ukabuda pawifi, mumwe munhu akapinda pawifi, iwo wabuda mumwe munhu akapinda, anogona kupiwa that same address. Apiwa that same address, ndikasenda information to this IP, am I sending to the first person angandiri kusendera? No, ndakutosendera mumwe munhu. Vari kushandisa the same IP address but two different devices dzakasiyana. So IP address is not very reliable to send information. That's why tine inonzi physical address, inonzi MAC address. So kana ndikashandisa MAC address, PC1 akauya, PC2 akauya, vane MAC address akasiyana vari two. MAC 1, MAC 2. IP address anogona kushandisa 1 iyoyi because mumwe munhu amva panetwork, mumwe munhu apinda abva apiwa same IP address. But ndikaenda noconsider MAC addresses avo anenge akasiyana. That's why ndikapiwa this IP address, ndinoshandisa ARP kubvunza kuti ko MAC address ndeipi, so that ndizive kuti the physical address chaiyo chaiyo ndeipi. That's why we have two types of addresses. IP address inogona kupiwa multiple devices achishandisa the same IP address. To be sure kuti kusenda papi, you need the physical address. Device on a remote network, device on different networks. Right, I've summarized that. Data link layer addresses, I've summarized everything. Layer Wireshark, done. So basically that is chapter 3. To summarize, basically that is chapter 3. What you need to know from my protocols up. Design, I need to insert a slide. Right. What you need to know from my protocols up is my layers are 7. Layers of OSI. You need to know my layers are 7. 7 layers of OSI. Each layer will perform what role? Starting point. Then protocol yakati iri layer ipi. You need to know kuti DNS iri layer ipi, iri layer number 7. IP iri layer number 3. You need to know that. Once waziva izvozvo, you need to know protocol interaction. Protocol interaction, send something to a server or just send an image. Send your image from PC1 to PC2. Then explain protocol interaction. Kuti pandiri send an image, ndikutangira ku-application. Now what happens, ndichidzika down the layers. Explain that using protocol interaction. Uri wega, that's how you start. Uri wega. Explain kuti ndikuda send an image ku PC2. What happens from application layer kusvika ndasvika ku-physical. Ndasvika ku-physical, then information yasendwa. Ndasvika pa-PC2. What happens ndasvika pa-PC2? Rakutora from layer iyi kwidza until rasvika ku-application. Ndikasvika ku-application foot, it's an image received, then ndakuona image yangu. Be able to explain that by yourself. It improves your understanding ekuzoti protocol interaction yakaita sei. Right. Then from there, what else? Know the difference between MAC and IP in terms of addressing. Look at a local network, look at a remote network. Two things. At a local network, MAC address, very useful. MAC address, source and destination is the receiving and sending device. But by remote, it's not the same. By remote, source and destination MAC, the source MAC is the same, ndokuri kubva information. but the destination mark inoita interface yeroute. Kuma IP though, the source and destination panapa is the same, the source and destination panapa is the same. Know the difference between those two types of addresses. And basically, that summarizes chapter 3. You need to learn about my protocols ESA. HTTP kuti inoitei uri wega. Find time to do that. DNS, DHCP, FTP inoita basa rei. ICMP, ping. I'm sure mese makamboshandisa ping at some point. Protocol iri inonzi ICMP. Be able to relate kuti ping and ICMP zvinofambidzana papi. I can spend the whole day talking. Kana muchine vanhu, any questions? Can we look at my questions with respect to this chapter before I clog out? Any questions? No, nada. Right. If there are no questions, the next thing is going forward now. Right. The next thing is chapter 4, chapter 5, browse. Musa DP saying anabasa chapter mabata sakanaka. Browse, no browser. Browse chapter 4, 5, 6, 7. Skip those. And probably by chapter 10. Tinoona basic router configuration. Tinoona kuti yakafanana ne chapter 2. Nyana. Zvada kufanana. Basic router, basic switch, and router configuration. Zvada kufanana. Chapter 2 and 10. Tichipedza topinda chapter 11. I have my videos at my channel. Chapter 11. Anokuintroduce kuti IP addressing. IP addressing, what is subnetting, how do you subnet, how do you configure a very small network yako over my IP addresses, or is a ping to check connectivity. I have a couple of videos starting at chapter 11. So don't even skip it. So pakati pesa waenda chapter 11 because I know chapter CCNA 2 my chapters are pakati ana physical layer, the data link layer, the Ethernet, the network layer, the transport layer, if you don't have time too much, skip them to end up. Meanwhile, I also need you to my exams, my module exams. Attempt my module exams. Ngapere ese. Why? Because administrator will do anenge ari monitor my accounts. So kana wakanyora one exam, one module exam at this point, and this is week and probably week around 8, 9, 10. Week 8, 9, 10. Week number chi. Makati enyaro week number chi. Arikuziva. I'm not so sure week chi. Arikuziva week chi. Anyone?
Week 8.
Right, week 8. So can you wakanyora module exam 1 week 8? It does not make sense. At least week 8. Wakanyora module exams probably 4. Or anosvika pa chapter around chapter 12. In my module exams, they are very easy to write. Ndakakupa a link rakanzi IT exams answers. Go to that link, munotarisa my exams, go through the questions, monyora my module exams. I'm allowing you to make a copy and paste my exams ngaperi. Then toteera tichiverenga. Admin wedu haazive kuti maita copy and paste here. Ndini ndozviziva. Then tochiteera tichiverenga. Togona topedza kusvika pa week 12. Taita ma exams ese musina kana chamuri kuziva. Then tochigara pasi totanga kuteera kusvika tapedza. Tikasata izvozvo ma exams akasapera, admin achiona kuti vanhu havasi kuita ma logins, havasi kunyora ma exams, achatanga kucomplaina, achatanga kuda kusunga discount. The first thing chaanoda kuti chidzira nacho kuda kusunga discount. Anotaura kuti class iyi haisi kuita zvine mazvo, discount tichanetsa kubuda. highly unlikely though discount rinonetsa kubuda, but I'm just saying. So let's try kuti mamodular exams edu attempt, even usina kuverenga that much, go through the questions. It's very easy. Go through